Okay, here we're looking at inverse functions. And inverse functions are a pretty straightforward idea. And the most important thing to remember for inverses are to switch x and y. So usually you have a function like y equals 2x plus 1. Usually you put in the x values for the input and then you get back y values for the output. So input is x, output is y. What an inverse function does is it switches those two values. So you switch the x and y value. So essentially you're given the output, you're given the y value, and you want to find x. So we'll see how that works out here. So I give you the directions in the calculator of how to draw the inverse on your calculator. So you can do that. So for each function, we're going to graph the function and its inverse. We're going to find the domain and range of the function and its inverse. And then is the inverse a function itself? And then write the equation of the inverse. Okay, so our first one, a basic linear equation, f of x equals 5/2 x minus 4. So the domain and range is negative infinity to infinity. So when you switch x and y, your old domain is your new range, and your old range is your new domain. So basically, these values are here, and these values are here. It's hard to tell because they're the same in each of them. So if you were to graph your function and its inverse, the function 5/2 x minus 4, we start down here at negative 4, and then the slope is 5/2, so up 5 to the right 2. There's your line. So to find the inverse, you switch x and y. So instead of y equals 5/2 x minus 4, you switch x and y. And then you solve for y to get y equals. So you add the 4 on this one, and then to get rid of multiplying by 5/2, you multiply by 2/5. So multiply both parts by 2/5, or both terms. So f inverse of x, so instead of leaving it as y equals, we want to clearly say this is the inverse function. So instead of f of x equals, we're having f inverse of x equals. So 2/5 x plus 8/5. Now if you're saying, well, gee, Mart, that's a hard graph to plot on a grid. Well, remember that you're just switching x and y values. So if you find a couple points that are on this function, just switch them. So for example, 0, negative 4 is on this function, your original. So 0, negative 4. So negative 4, 0 is on your inverse if you switch x and y. Another point we had was 2, 1 was on our original function. So 1, 2 is on our inverse. Okay, so now moving along, we have g of x equals the square root of x minus 2. And you can graph that in your calculator. But the domain will be x is greater than 2, so 2 to infinity. And your range of your original function was 0 to infinity. So right here is what that original function looked like on your graph. So if you switch x and y, your old domain is your new range, and your old range is your new domain, because all you're doing is switching x and y. Okay, and yes, g inverse of x is a function. So when you graph it, we can see that each x has only one y. So the equation of the inverse, again, you switch x and y, so x equals the square root of y minus 2. To get rid of the square root, you square each side, so that'll get rid of the square root here and give you x squared on the left side, and then add the 2. So g inverse of x equals x squared plus 2. Now this is where you have to be very careful, and this is the equation of your inverse, but remember, your domain of your inverse is only 0 to infinity. So you only graph it on that domain. G of x equals x squared plus 2. So if you were to graph that whole thing, there's another half of a parabola there. But because of your inverse function here, because our new domain is our old range, we're only graphing when x is greater than or equal to 0. Okay, and then the last couple, again, I would suggest you pause the video and try these last few. Okay, and I'll put up the answers to these. So there's number 3. Nothing too crazy going on there. Just that to get rid of a cubed, you cube root or raise it to the 1/3. You could also say this is h inverse of x equals x to the 1/3. And then your graph is given here. So the cube root of x, that's this right here. And then x cubed, this one here. And then number 4. We have a square root of x in the denominator, so that means x has to be greater than 0 in order to get answers. So this one's kind of a weird graph with its inverse. Oops, I forgot to put parentheses there. So when you switch x and y here for the inverse equation, you cross multiply, or multiply each side by square root of y, and then divide by x. So the square root of y equals 6 over x. And then if you square both sides to get rid of the square root, that'll give you 36 over x squared equals y. And again, that's only graphed when x is greater than 0, because your new domain is your old range. So how can you tell whether the inverse of a function will itself be a function? There's a few different ways. One way is to look at the original function and see if it passes the horizontal line test. Remember that we usually can look at a vertical line test to tell if your function, to tell if your graph is a function, the vertical line test. Well, the vertical line is x equals. If you switch x and y for the inverse, now we're looking at y equals. So on your original function, if your original function passes a horizontal line test, meaning your horizontal line, anywhere you draw it, only hits your original function in one spot, that means that when you switch x and y, each x value on your new function will have only one y value on your old function. The other way is to examine your original function and look at, does each y have only one x? So does each y have only one x on your original function? And if it does, then the inverse will be a function. Now the idea of each y having only one x and each x having only one y, so going both ways there, that's the idea of what we call a one-to-one function. So if f of x is 1-to-1, meaning each y has only one x, then the inverse will also be a function. Okay, so those are inverse functions. Remember, switch x and y is the big idea behind inverses.